Okay, welcome Precalc C. This is going to be like a 5-minute video, I promise. Maybe less. This was page 2 from the complex roots packet. And okay, I know from experience that some people find this problem kind of weird or confusing or difficult to understand. Usually I go over it in class really fast one day, but alright, now we're just going to do it on video. What is going on? Well, this is kind of a follow-up on what we did in class Monday and Tuesday on understanding the sort of shapes of graphs and talking about the number of real roots and the number of complex roots, non-real roots, and double roots and stuff like that. So this was just like a fun little problem. So here we are presented with a polynomial. This polynomial is called g, and this is a picture of g here. It is a quartic. It has a relative max at height 6, a relative max at height 11, a relative min at height 2, and its leading coefficient is negative, so its end behavior is negative in both directions. And now a new function is introduced to you, and this new function is well, it's this function but moved by some amount. So the function is called f, and well, it's g, but some vertical translation of g, so moved up or down. And now the question is, they ask you how many real and how many non-real roots does g have? Well, clearly it has two real roots because there they are, -7 and 11. And then the other two are non-real because it's a quartic with 4 complex roots. Okay, and now the question is, the real question is, for what values of c will f have? And then there are these 6 categories, which I've kind of reproduced here on the board, matching up to the kind of order and position of them on the worksheet. And the question is, under what values of c, in other words, how do I have to move this function g in order for it to have these 6 categories? Okay, I think the best way to do this is not to try to visit these categories one at a time, but instead to just kind of go in order, chronological order or something, for all the different things that c could be. Okay, so let c be, -1,000,000 or something like that. Well, if c is -1,000,000, then the graph f, which I'm about to answer questions about, looks exactly like the graph g, except it's been moved down. And if you move this function down by, -1,000 or something like that, well, then the entire graph is going to exist underneath the x-axis, and so it's going to have no real roots. And if it has no real roots, then all of its roots are non-real, and so that's that. And so, in fact, if c is -1,000,000 or -1,000 or -100, or actually anything less than -11, then because 11 is the highest point on this graph g currently, if I were to move this whole function down, more than 11, then the whole thing is going to exist below the x-axis. And so, okay, I'm ready to kind of to give sort of an answer now here. Where is it? 4. I will have 4. Yeah, I don't need to look at my answer key. I know what I'm doing. I will have 4 non-real roots when the entire polynomial is below the x-axis, which will happen for everything from -∞ to -11, exclusive. Okay, now what if c is exactly -11? Well, now use your powers of imagination to picture this entire graph g being moved down by exactly 11. Well, if you move this down exactly 11, then this relative max here is now on the x-axis, then that's going to be a double root. And so under that condition, we will be here. We will have one real double root at 8, if c is -11, and then the other 2 roots will be non-real. Okay, but what if now c is a little bit more than -11? -10, -9, something like that. Well, if c is like -10, -9, then that's kind of equivalent to let's see, I need like a big stick or something, but well, that's equivalent to this sort of x-axis now kind of running through this chunk of the graph, right? I think it's better if you just use your imagination. Move this entire thing down, say, 10. Well, if you move it down 10, then this point 811 is going to sort of be peaking over the x-axis, creating two real roots. And then the other two will be non-real. So that is two distinct real roots, two non-real roots. If C is anything from -11 to, well, when does that works if I move it down -11 or, well, I have to consider this -6 number. So if this is anything between -11 and -6, then I will have two distinct real roots poking out from among above the x-axis and two non-real roots. But of course, if I move this g function down by exactly 6, so in other words, if c is -6, now this relative max is touching the x-axis, is tangent to the x-axis, giving me another double root at 4.5. So that puts me in the category of two distinct real roots and one real double root if c is exactly equal to -6. And now if I move c down, like say -7, if I move this entire graph down by -7, now the x-axis is going to sort of pass through through this polynomial 4 times. And so I'm going to get 4 distinct real roots if c is anything from -6 to -2. And that's because if c is equal to exactly -2, then that's equivalent to the x-axis being here, and well, now that's going to touch, to be tangent to this relative minimum. So that puts me here now, right? Two distinct real roots and one real double root. Yeah, that's right. If c is in fact exactly equal to -2. But now, if I move this down less than -2, like if I only move it down, say, -1, for example, well, then it's going to look basically just like this. And we already agreed that if c is like -1, or in fact if c is 0, then I am in the category of two distinct real roots, two non-real roots. And so this is going to be true also everything from -2 to infinity. Yeah, because now I'm imagining now c, I've been slowly letting c get bigger and bigger. If c is like 2, say, then this thing gets moved up 2. If c is 5, it gets moved up 5. And in fact, you can move this graph up 1,000,000. It's still going to have two real roots. And so I think I'm just done. I have gone through every single possible value of c. Let me just check to make sure I didn't do anything wrong, but I don't see how I could have. And in fact, the answer to this is just the empty set. There is no value of c for which there are going to be two real double roots. All right, so that's the entire problem. Goodbye.